Alright folks, in this lesson we're going to build towards writing exponential functions to model percentage change. Okay, so we're still working within our just sort of standard exponential function here, a b to the x power, right? So this is an exponential function, and when we're dealing with percentage problems, we can actually change that b to something a little bit more specific. So y equals a, instead of b, I'm going to say our shortcut from the last couple lessons here, 1 plus r to the x power. Okay, so we can think of exponential functions involving percents using this sort of standard form. Okay, so let's take a look at some problems and what they look like here. The first little chunk of this assignment is pretty easy. So all I want to do is decide whether the change represents growth or decay. Decay, by the way, means like shrinking, getting smaller. And then determine the percentage rate. So in other words, we want to find that r. Okay. So the way we're going to do that is just look at that point, our b. And here our b is 1.01. There's a couple different ways to think about this. You guys are probably smart enough to think of like this being 101%, because I moved the decimal point over twice, right? And then 101%, well, that's just 1% growth. It's 1% more than 100, right? Or I can think of it algebraically. I can say 1.01 is equal to my 1 plus r, and then r would be 0.01, which is still 1% growth. Okay? So in these problems, all you're doing is zeroing in on that kind of 1 plus r part of the function to determine if it's a percent increase or a decrease. And doing this is going to allow us to write models to model sort of real life problems more easily. Let's do one more. The only thing that you might find tricky, this is the same type of problem, so we're going to zero in on that b. So this is, we'll do this one algebraically. We'll say 0.23 is equal to 1 plus r. So now I can subtract 1 on both sides, and you'll get r is equal to 77.77 or 77%. Okay, so the only trick here is when there is a decrease. So when this base is less than 1, you have to subtract that number from 1, which is how I got 0.77 here. So we'd say this is a 77% decrease. So in other words, when there is a decrease, you can't just read the decimal from the base here. You have to do a little bit of math. Okay? So like our rule, we could say, is that if b is bigger than 1, that means we have a growth situation. And then in this case, we had a b smaller than 1. That means we have a decay situation. Okay, so in your homework you'll identify like growth or decay and the percentage, I believe. Okay, and then in the next section we will do some problems where we need to write the function and use it to solve a problem. Okay, so you got to read the text. So quantity with initial value of 920, well, that tells us that our a in our exponential model is 920. Decays exponentially at a rate of 85% every week. What is the value of the quantity after 21 days to the nearest hundredth? Okay. So we'll use our 1 plus r as our base. And in this case, it's going to be 1 plus negative 0.85 because it's decaying, right? Which gives me 0.15. And then my model, y equals my initial value times 0.1 0.15 to the t. And remember, t is in weeks, so that's good to note. Okay, and we want 21 days. So we have to do a little conversion there. 21 days is 3 weeks. So our last step is going to be to say t is equal to 3. And then you can type this into your calculator exactly as you see it. Remember, the little caret gives you the exponent, and you get 3.1. And I rounded that already. I got 3.105, and I rounded up to the nearest hundredth, as it says in the text. Okay. And there's no label because it doesn't give us a whole lot of context here. We'll do one more. So we have another exponential decay problem. So that means our rate is going to be, or our base rather, is going to be less than 1. We have an initial value of 5,500, and our rate of decay is 5% every 8 hours. So this one's a little bit trickier with the units. What is the value of the quantity after 1 day to the nearest hundredth? So I'm going to build my function. Y equals my initial value, 5,500, times, here I do 1 minus 0.05, which is 0.95 to the t. And then our units given were every 8 hours. So 1 day is 24 hours, or 3 times 8 hours. So I have to do a little bit of thinking about my units in some of these problems. 3 times 8 hours. So what that means is my t is 3. I'm going to plug that in. And what do I get here? I plug that into my calculator exactly as I see it, and I get something like 4,715.56. And again, I rounded there. I rounded down. 0.5625 becomes 0.56. Okay. So these are just building the model, figuring out what your t is. So this step is the tricky step. The point here is to practice writing these models with percentages, and then these units are going to make you think a little bit harder.